everyone is fine, and it is good to see all of you in the class just within 2-3 minutes. So that's very good. So yesterday we were studying about the Mohr circle. So we have discussed about the basic principle of the Mohr circle. So now we are going to study the formation of the Mohr circle, that how we have to form it. Okay, so this is somewhat sort of a little bit derivation. So let's start it. Just a moment, please. So let me start the recording. So Bismillahirrahmanirrahim, let's start with our today's lecture. So this is our Mohr circle. So one thing is, you guys did not ask yesterday that why this was over reference line CP. I told you that this is over reference line, and with reference to this line, or you can say the plane, you measure the orientation of principal planes. Moving from CP towards counterclockwise direction, and then moving from CP, which was basically our reference plane, we move towards clockwise direction to get the orientation of the shear planes. So first you have to establish the coordinate axis. Horizontal is normal stress, vertical is shear stress. Shear stress is positive downwards. It will be seen that this equation 911 is this sigma x dash minus sigma average square plus tau x dash y dash square is equal to r square. So this equation 911 will be seen that this equation basically represents a circle having a radius r and center on the normal stress axis at point C. The coordinates of point C are average normal stress and 0. Shear stress is 0. So this is the center point of the Mohr circle. Origin of the axis is this one, 0, 0. Fine. There can be a possibility that your center lies over the origin, but in general these are two different points. Fine. And center on the normal stress axis at point C, which is the center of the Mohr circle, having the coordinates average normal stress and 0 shear stress. This circle is called Mohr's circle. Mohr circle, why it is called Mohr circle? It is because this method was developed by a German engineer Otto Mohr. So after his name, it's Mohr circle. Okay, now we will start with the basics. That why we are having a reference line. What does a reference line mean? And then what about sigma y? So these are the 2 points about which we are going to study now. So each point on Mohr's circle represents 2 stress components. So each, just like your regular x and y axis, this is now normal stress and shear stress. So each point on the Mohr circle will have a particular set of normal stress and shear stress values. So acting on the side of the element defined by the x dash axis when the axis is in a specific direction. So what we are actually trying to say, I think I should draw the figure for clarity. Okay, Ji. Now we are saying that each point on this Mohr circle, ठीक है जी, it has specific value of normal and shear stress. ठीक है. Now see this. This was our element. ठीक है जी. This is our element. Fine. This is sigma y. Let's say this is sigma x positive. This is your shear stress. ठीक है जी. So this is your element. Now, when you rotate your element, sorry. ठीक है जी. Now, when you rotate your element, let's say at theta 1. This is your theta 1. So this is your x dash axis. ठीक है जी. And this one is your y dash axis. ठीक है जी. So you can calculate the stresses over this transformed axis. ठीक है जी. Now let's say you have another orientation. Let's say this is theta. Let's say this is theta 2. ठीक है जी. Now this x double dash and y double dash. ठीक है जी. Their transform normal and shear stresses values will be different from x dash, y dash. Fine. Now on the Mohr circle, this is your center. So first thing is we just need to mark the reference. So what will be the reference? Anything, what does it comes to your mind? What will be the reference? If you see this figure, in this figure, I am taking this black color x and y axis, the regular x and y axis as my reference. Means my reference is theta is equal to 0. ठीक है जी. my reference is theta is equal to 0. Means to say that reference plane is that plane in which the rotation is 0. So it means whatever is the plane stress state conditions given to you. So whatever is the value of sigma x, the same will be the value of sigma x dash. Whatever will be the value of sigma y, the same will be the value of sigma y dash. ठीक है जी, same will be the value of y dash. ठीक है, so guys please write few lines. I will draw the figure. ठीक है जी, figure I am using this one. So this is your x-axis. ठीक है जी, and let's say black color we are using as a reference. So this is your x-axis and this is your y-axis. So after rotation theta is equal to 0, after the rotation theta is equal to 0, what will happen? Your rotated axis, x dash axis, will be coinciding with your regular x and y axis. Fine. So it means that for my reference case, this is x, this is y. Okay, for reference case theta 0, this will be x dash and the same will be y dash. Fine. So it means for my reference axis, ठीक है जी, after orientation of theta 0 degrees, x dash coincides with x-axis, y dash coincides with y-axis. So guys, please write this. When x dash, this is x dash, and over reference is x. ठीक है जी? So please write. When x dash is coincident with x-axis, when x dash is coincident with x-axis, then theta is 0. You can see this theta is 0. In this case, you have some values of theta, but here when x dash axis is coincident with x-axis, then your theta will be 0. ठीक है जी, theta 0, x dash axis coincides with x-axis, y dash axis coincides with y-axis, theta is 0, and your shear stress in this case will be, now if I write this, sigma x dash will be equal to sigma x for this 0 case. ठीक है जी, and tau x dash y dash, tau x dash y dash will be equal to tau x y. Fine ji, is this point clear? ठीक है जी, so theta 0 because x dash axis is coinciding with x axis, y dash is coinciding with y. So this means this is now we are getting the normal reference what you say plane. So reference plane is the one on which orientation is 0, means the x dash axis is coinciding with the reference x axis, y dash axis is coinciding with the reference y axis. Fine. So now I have this average point C. ठीक है जी, average normal stress, shear stress 0, the center of the Mohr circle I have it. Now I need one point to mark the reference plane. I need one point to mark the reference plane. And we have said what are the coordinates? The coordinates of this point are average stress, sigma average, and 0. So these are the coordinates of this center point. Now the coordinates of your reference point. Reference point coordinates will be normal stress is equal to sigma x. Sigma x dash is equal to sigma x, so same sigma x. Okay. Then shear stress is equal to tau xy. Tau xy. So these are basically your coordinates of the reference point. Sigma x and tau xy. These are the coordinates of your reference point. Now we know that sigma x is positive, so it will be somewhere here. Tau xy is positive downwards. So let's say we found out we have to mark the point of Mohr. Let's say this is when you will mark it, you get a point somewhere here. You get it? So this basically is corresponding to sigma x and corresponding to tau xy. Now, this point is basically over reference point A, because you will be given the plane stress conditions. You will be given plane stress conditions, means sigma x, sigma y, tau xy will be given, and then onwards you will be required to calculate the principal stresses and normal, shear stresses, average normal stresses. So first you have to calculate you have to mark the reference point A. So this will be reference point A. So this is your C to A. This is your reference plane. This is your reference plane. So this is for one given condition. Okay, for different conditions, your reference planes will be different. Okay, but the procedure is first I have to mark the center point of the Mohr circle, whose coordinates are average, normal stress, and 0. And I have to mark the point A, which is my reference point, whose coordinates are sigma x and tau xy. Why we are getting the same coordinates? Because theta is 0. X dash axis is coinciding with x axis. Y axis, y dash axis is coinciding with y axis. Is this point clear? Is this point clear, guys?
Yes, sir.
Okay, if this is clear, so this is one point. If you see this, if I want to mark the coordinates, so this is basically we have said sigma x. This is sigma x. This is tau. Sorry. So this point is now A. This is my reference point A. Its coordinates of this reference point A are sigma x and tau xy. Now we have marked sigma x, but still we have to mark sigma y. Sigma y is not yet being marked, so we have to mark it. So now what we are going to do, we are going to rotate the axis. So in that case, over now the second point, to mark the second point. Yet this is a point which is reference point. Now we have to mark another point which is basically over G point, which basically represents the coordinates of sigma y comma tau xy. Okay, so let's do that. Now in that case, you will rotate your axis by 90 degrees counterclockwise. ठीक है जी? Theta is 90 degrees theta is 90. Guys, can you hear me now?
Yes, sir.
Yes, sir.
There was a thoda sa hua tha internet. Okay. Now this is your actual element. Now I will draw the figure in which the element will be rotated by 90 degrees counterclockwise. Okay. See your regular x-axis and y-axis. Now the rotation. When you will element in the base बना लेते हैं. This is x, this is y. Okay, when you will rotate your element by 90 degrees, so what will happen? क्या होगा? Your x dash axis will be here. यही होगा ना? This angle will be now 90. ठीक है जी? X dash axis is oriented at an angle of 90 degrees counterclockwise. So X dash axis will be along the Y axis and Y dash axis will be along the X axis. ठीक है जी? So this is your X dash axis and this is your Y dash axis. True? This point up till here it is okay?
Yes, sir.
So now on the element, this will be your X dash axis. ठीक है जी? This will be now your Y dash axis. Again, this will be your X dash axis. This is your Y dash axis. Everyone fine with this?
Yes, sir.
Okay. Now in this case, what will happen? Sigma x dash. Sigma x dash will become क्या होगा जी? Now you can see sigma x was here. Now sigma x dash is along this axis. So this is equal to sigma y. So this is equal to sigma y. Sigma x dash axis is equal to sigma y. And tau x dash axis, y dash axis is sigma, tau x dash, y dash axis, its value will now be, earlier it was, let's say, should be drawn with the black. 1 second, please. ठीक है जी, fine, and now it will be rotated. ठीक है जी, so tau x dash y dash will be minus tau x y. Fine. So now the coordinates of your point G, ठीक है जी, ये रेफरेंस पॉइंट था A. Now we are calling this point as G. ठीक है जी, G. So the coordinates of this point will be sigma y, comma minus tau ठीक है जी, sigma y minus tau x y. Fine. Now if you see this over here, we have said shear stress is negative upwards, so this point will be exactly like opposite to this point here somewhere. ठीक है, the coordinates will be this one. ठीक है, although just because of the figure which we have drawn, इसको मैं ठीक कर देता हूँ, just give me a moment, क्योंकि आपका वो जो है वो नेगेटिव आना शुरू हो गया. Just give me a moment. ठीक है जी, so and this is your, you can say, minus tau x. ठीक है जी, and this is negative sign. This point is clear, reference point A and this point G. Are these 2 points clear? If you have any question about these 2 points, you can ask me now. If it is clear, then we use it.
सर
If it is
क्लियर है, नो क्वेश्चन.
okay, ji. Now let's go through this thing. It's the same which we have already done. Each point on the Mohr circle represents 2 stress components, sigma x dash and tau x dash y dash, acting on the side of the element defined by the x dash axis. When the axis is in specific direction, then comes over case 1, when x dash is coincident or coinciding with x-axis, means theta is 0 degrees, so sigma x dash will be equal to sigma x, tau x dash y dash will be equal to tau xy. ठीक है जी, and this will be over reference point A, and the coordinates of this reference point A are sigma x and tau x y. Now the second case is we rotate the element by 90 degrees counterclockwise. Okay? When we will rotate the element 90 degrees counterclockwise, we will get sigma x dash is equal to sigma y, and tau x dash y dash is equal to minus tau xy. These are the values of the coordinates of the point on the Mohr circle G point. Okay? Sigma y and minus tau xy. ठीक है जी. So when you are given the element, ठीक है, you can simply mark these points. Reference point A sigma x tau xy, G sigma y minus tau xy. Fine. And then the radial line CG is 180 degrees counterclockwise from the reference line CA. Now this is interesting point that on the element you have rotated the element by 90 degrees. ठीक है जी. The element was rotated 90 degrees. However, element was rotated 90 degrees. However, on the Mohr circle, the difference between point A and point G, the difference between point A and point G is 180 degrees. Fine. So, which means the radial line CG. ठीक है जी. Let me show you on the circle. So this radial line CG is basically 180 degrees from this reference line CA. CA is my reference line. CG is 180 degrees. So on the Mohr circle it is 180 degrees, but you have rotated the element by 90 degrees. So it means rotation on the element will be 2 times of rotation on the Mohr circle will be 2 times of the rotation on the element. You can see here theta, over here you can see 2 theta. So they are clearly showing you theta and 2 theta. Fine. So in other words, rotation theta of the x dash axis on the element will correspond to a rotation of 2 theta, will correspond to a rotation of 2 theta, fine, on the Mohr circle in the same direction, in the same direction. Guys, this thing we will what you say, discuss in a short while, and this will also give you the answer to your question that why we are taking shear stress positive downwards and negative upwards. Fine. So this will also give you an answer to this. Now once the Mohr circle is constructed, it can be used to determine the principal stresses, in-plane shear stresses, normal stresses, then any transformed normal stress as well. ठीक है जी, because all these points on the Mohr circle, they represent a set of normal and shear stress. A set of normal and shear stress. So this point is the one that why we are taking shear stress for positive downwards. The reason is we are now, by taking the shear stress positive downwards, we are having what you say the rotation on the element and the rotation on the Mohr circle in the same direction. Means here it was, we are taking counterclockwise. Fine. So here it was also counterclockwise. Fine. On the other side, if you take shear stress positive upwards and negative downwards, then this rotation 90 degrees counterclockwise will be presented by 180 degrees clockwise on the Mohr circle. Rotation direction will change. So to have the same direction of the rotation on the element and on the Mohr circle, we take the vertical axis negative upwards and positive downwards. Positive downwards. ठीक है जी? Is this point clear?
Yes, sir.
Okay. So now this is the complete procedure is given. ठीक है. Now very simple, I will let you know and we will understand, because see, from this figure, before we go further, everyone is clear that how we have determined the center point of the Mohr circle, how we have marked the what you say, the reference point A, how we have this resultant, okay? How did we get this point G? If you are clear with A, C, and G, then I will proceed further. If it is clear, then let's start with the procedure for the construction of Mohr circle. First step is we have to establish the coordinate axis. We have to establish the coordinate axis. ठीक है जी? So this is your normal stress, this is your shear stress. Vertical axis is your shear stress, and shear stresses, they are positive downwards and negative upwards. Shear stresses are positive downwards and negative upwards. Normal stress is positive towards the right, negative towards the left. Same. ठीक है जी? So no change. Clear? Then first thing is establish the coordinate axis that you have done. Now the next step is you have to mark the center point of the Mohr circle. Now to mark the center point of the circle, or to plot the center point of the circle represented by C, what you have to do, you have to calculate the average normal stress. Average normal stress is equal to sigma x plus sigma y over 2. So you can see this, we have to calculate the average normal stress. The coordinates of the point C are sigma average and 0. So you get your center of the Mohr circle. Fine. This point okay. Now next thing is next step. You have to mark the reference point A. ठीक है जी, reference point A has the coordinates sigma x and tau xy. The coordinates of reference point A are sigma x and tau xy. This reference point A represents the normal and the shear stress components on the elements. ठीक है जी? When your x dash axis is coinciding with x axis and y dash axis is coinciding with y axis. So this is my reference point A, having the what you say coordinates sigma x. ठीक है जी? You can see this. I have the coordinates sigma x and tau xy. So this is my reference point A. Next thing is I have to connect C, the center point of the Mohr circle, to the reference point A. I will connect these 2 points and I will draw the radius. ठीक है जी? So I will connect these 2 lines, 2 points, and this will give me the radius of the Mohr circle. What I have to do now, I have to place my compass here, open it equal to the radius, draw the Mohr circle. ठीक है जी? So this is the first step, construction of the Mohr circle. ठीक है? So now we have the Mohr circle with us. Now we want to calculate orientation of the principal planes, orientation of the shear planes. I want to calculate the magnitude of the principal stresses. I want to calculate the magnitude of in-plane shear stresses. ठीक है जी? I want to know the orientation of the principal plane, shear planes. So all I can now do step by step from this Mohr circle. So this was the first step, construction of the Mohr circle. If you have any question about this, ask me now. Any questions? Any questions? No questions, then we are proceeding further. Now, next thing is, I want to know the orientation of the principal planes. I want to calculate the principal stresses. Okay? I want to know the orientation of the principal planes, and I also want to know the magnitude of the principal stresses. Okay? Let me show you one figure I have. Let me see. Figure 12. I think this will be more appropriate. So I have we have drawn the Mohr circle. Now next step is, this is your reference point A. This is your reference plane CA. CA is your reference plane. Okay, ji? Now I want to know the orientation of the principal plane. We have earlier defined the principal planes are those planes. Principal planes are those planes over which principal stresses are maximum or minimum and shear stresses are zero. So you can now see this horizontal axis, normal axis, stress axis, over which your shear stress value is zero. Over this axis, shear stress value is zero. Over this axis, shear stress value is zero. So it means my principal plane is this line, horizontal line. My principal plane is this horizontal line. ठीक है जी? So this is this point clear, that this my horizontal line is my principal planes. Now orientation of the principal planes I can find with reference to my this line CA. So moving from this reference line CA towards CB will give me the orientation of the principal plane 2 theta P1. We know that the difference between 2 theta P2 and 2 theta P1 will be 180 degrees. So continue from here to here, this will give me 2 theta P2. And you can see the difference between 2 theta P2 and 2 theta P1 is 180 degrees. The difference between 2 theta P1 and 2 theta P2 is 180 degrees. That's one more thing to be noted. This point is clear, the orientation of the principal planes.
Yes, sir.
Okay, now next thing is, I need to calculate the principal stresses. We have said that the maximum normal stress and minimum normal stress, these are my principal stresses. So this one will be my major principal stress, this one will be my minor principal stress. Always guys, remember one thing, that the larger stress, larger normal stress will be your major principal stress. Smaller principal stress, figure it, will be your minor principal stress. Now, this sigma 1, it is defined by this. From moving from the reference plane CA towards CB, you will get 2 theta P1, which should give you sigma 1. Then moving from the reference plane in the same direction, in the same direction. So moving from the reference line CA in the same direction towards CD will give me 2 theta P2, which will give me sigma 2. Fine. Fine. So this is now from the Mohr circle. This was the point related to the orientation of the principal planes. So over the principal planes, we know that the shear stress is zero. So this is my principal plane. This is the orientation of the principal plane. 2 theta P1 and 2 theta P2. This is sigma 1. This is sigma 2. Done. Now move further. Next is there is one point which I want to read for you, that how to measure this 2 theta p1. आप इसको कैसे measure करेंगे? You can simply measure it by using trigonometry. ठीक है जी? By using simple trigonometry, you can find the value of 2 theta p1. ठीक है जी? And remember thing, 2 theta p2 will be simply 180 degrees plus 2 theta p1. So you will get 2 theta p2. So this was your major and minor principal stresses, orientation of the principal planes. Now, next thing is we want to calculate the orientation of the shear planes. ठीक है जी? Now, shear planes is this line. One more thing, sorry. This major principal stress is represented by point B. Minor principal stress is designated by point D. ठीक है? A reference point, major principal stress, center point of the Mohr circle, minor principal stress. Then comes this EF. We have said that over the shear planes, we have earlier studied that over the shear planes, we will get the maximum in-plane shear stress. Okay, we are getting this point E, which is the maximum in-plane shear stress, because shear stress is positive downward. So we are getting maximum in-plane shear stress at point E. Then we are saying that over the shear planes, we will also get the average normal stress. So of course, we are getting average normal stress over the principal planes. So this line E to F represents over shear plane. ठीक है जी? Represents the shear plane over which you have the maximum in plane shear stress and you have the average normal stress. Now, E and F, these are your shear stresses. This is maximum because this is positive shear stress, this is negative, so this is minimum. So we need maximum in plane shear stress, so that we get here. Now next thing is I want to calculate, because the next thing is I want to calculate the orientation of the shear plane. So moving from the reference plane, CA, it will always be your reference plane. CA will always be your reference plane. So moving from CA towards CE, this will give me the orientation of the shear planes, 2 theta S1, 2 theta S1. ठीक है जी? So whatever value you have got it here, let's say you have got 50 degrees. So this will be 90 minus 50. So 2 theta S1 will be 40 degrees. ठीक है जी? 2 theta S1 will be 40 degrees. Then 2 theta S2. ठीक है जी? Moving in the same direction as 2 theta S1, you will get, moving from reference line CA towards the plane CF, you will get 2 theta S2. The difference between the two should be 180 degrees. Is this point clear? Any questions? Please ask me now. Any questions? Okay. Next thing, the last thing which we need to study is, let's say you are given in a question that you have to calculate the coordinates of the point which is oriented at an angle, let's say any value of angle, let's say 20 degrees on the element. Okay. Now from the Mohr circle, how you will find that coordinates? 20 degrees counterclockwise on, this is one arbitrary value of theta I am taking. You, ठीक है जी, कोई value भी ले सकते हैं. It can be 21, 2, 3, whatever value you have. So let's say we have 20 degrees counterclockwise on the element. So on the Mohr circle, it will be 20 times 2, 40 degrees counterclockwise. So what you will do, this is your reference line CA. So moving from the reference line in the counterclockwise direction, you will measure 40 degrees. And where you will get the 40 degrees, you will draw the line. And where it bisects the Mohr circle, that will be your point of interest. You can then simply find the coordinates from here, sigma x and shear stress, and you can get the coordinate of any point. ठीक है जी? Any point. उस point को कहते हैं P point. Any arbitrary point. P. Is this point clear? This figure very clearly differentiate between all the normal uh, principal stresses, maximum influence shear stresses, orientation of the principal planes, orientation of the shear planes, etc. Any questions? If no question, then we are coming back. So in the book, in the book, the same first step is to establish coordinate system. Then you have to mark the average point. Then the third step is you have to mark the reference point. ठीक है जी? यहाँ पे first you see mark the center point, then you mark the reference point, then you connect C to A, and that is your radius. You get the circle. Then you have to get the principal stresses. Sigma 1, sigma 2, always remember major principal stress is sigma 1, minor principal stress is sigma 2. Rest is the same which we have done. Reference line is always CA. B is the major principal stress, D is the minor principal stress. So moving from the reference line CA to CB will give you 2 theta P1. Moving from the reference line CA to CD in the same direction will give you 2 theta P2. And the difference between the two should be 180 degrees. Then, the average normal stress and maximum in-plane shear stress components are determined from the Mohr circle at the points E or F. E is the maximum in-plane shear stress, which represents the positive value of the shear stress. Then moving from the reference line CA to CE will give you 2 theta S1. Moving from CA to CF will give you the orientation to theta h2 in the same direction. Last thing which we have discussed is this, that defined by any angle theta. ठीक है जी, आपको उसने कहा कि जी angle theta है, we want to find the stress components of this. ठीक है, so whatever is that angle, you will take the double of that in the same direction. You can see this same direction to theta from the radial reference line CA and draw the line CP. Where this line cut the Mohr circle, that will be your point P, and from the Mohr circle you will get your what you say coordinates. Any questions, guys? No questions? If no questions, then thank you very much for your time. Next time we will be doing more circle questions, problem state, numerical. So please do bring your copy pencil, okay? And if you have a compass, that will be fine as well. Okay, ji? So I will see you on Wednesday. So on Wednesday, please come prepared and do revise the lecture before coming into the lecture, before coming into the class. Okay, ji? Thank you very much for your time. I am going to end this meeting because I have a class again at 11.